Hi there! Thanks for watching my video on analyzing graphs and tables. This video is going to go over all the different things that we need to look for when we're analyzing a graph, and then we'll learn how to translate that over to analyzing a table. So when we're analyzing graphs, we're going to be talking about graphs on our XY grid. Now the first thing we need to know is some key features of a graph. And these key features exist whether the graph is linear, quadratic, cubic, or any other polynomial graph. The first key feature that we want is the x-intercept. Now if you think of the word intercept, like in football, intercept is where the football player crosses paths with the ball on its way to somebody else. So the x-intercept is going to be the points where the graph crosses the x-axis on its path to somewhere else. So if we look at this picture, the x-intercepts are here in blue. Here's our x-axis, and right here are the 2 points that the line crosses the x-axis. We write our x-intercepts using the x-coordinate, so in this case that's 5, and then the y-coordinate is 0, so 5, 0. And our other one is over here at -1, 0. Now, just like there's an x-intercept, there's also a y-intercept. And the y-intercept is going to be the point where the line crosses the y-axis. So in this case, let's change colors to color code it. Here is our y-intercept. And it looks like this graph is counting by tens. So that looks like it's maybe down at -8. Now this time we have to be careful because the y-coordinate is -8, but now the x-coordinate is 0. So we have to make sure we put our zeros in the right spots when we do our x-intercepts and our y-intercepts. Now domain and range. Domain is going to be the x values in our graph. So in this graph, if I look on each end, I see that there's an arrow going on each end. Arrows mean infinity. So that means this graph is going to keep going forever and ever and ever in this direction and forever in that direction, meaning the domain in this case is going to be all real numbers. So if I were to put this graph and zoom out, I could zoom out forever and it's just going to keep going. The range, on the other hand, is the y values. If we want to know which y values are in the graph, we need to look going up and down. Now, again, if I look at these arrows are both pointing upward. So that means it's going to get bigger going up forever and ever. So that means it's going to go to infinity in the upwards direction. But what happens when we go down? If I follow the graph down, I see that it hits this minimum point right here before it starts going back up again. That means that we're never going to have a value below that purple line. So that purple line looks like it's at -90. So we would say the range is that the y values always have to be greater than or equal to -90. So that tells us -90 is the absolute minimum it can be, and then it's going to be any y value going up. And domain and range you'll be practicing in most sections in all math courses. Because domain and range are really important for us to know what values are possible and which ones aren't. Now, some other features that we're going to be looking at is we're going to be looking at when is a graph positive versus negative, when is it increasing versus decreasing, when does it have minimums and maximums, and what's the end behavior, meaning what does it look like on each end. So as we're doing these sections, what I want you to think of being on a roller coaster. A roller coaster has its ups and its downs, and it can go up and down many times in one ride. And you hit that high peak, and then it drops you down, and you'll hit the lowest point, and it'll shoot you back up again. These are what we call our minimums and our maximums. The arrows here represent our direction of if our roller coaster is increasing or going up, or decreasing and going down. So whenever we're doing these, I want you to start thinking about, well, if I was on a roller coaster, what would that feel like? So first, before we can actually talk about those, we need to talk about something new called interval notation. Interval notation is how we're going to denote specific sections of the graph we're looking at. So if I were to go back to my roller coaster here, maybe I just want to know when are the sections when my roller coaster is going up. And if I look at my picture, I can see it's going up from here to here. It was climbing. And then it also was climbing from this point to this point. So if I wanted to just talk about those two areas where it's going up, we would use interval notation to signify those two sections. And then we ignore those other areas because we don't care when it's going down. So that's what interval notation is going to be used for in this section, is to specify specific chunks of the graph while ignoring others. Now, interval notation can be confusing because we're only going to use the x values. So when we use interval notation, we're going to use the x's to show where on the graph it is, but we're never going to use the y coordinates to show where it is on the graph. We just want to know the beginning and end points. When we're using interval notation, we're going to use these brackets for now. Technically, the brackets mean including that number. Later on, you'll use parentheses also, and that's if we don't want to include that number. So if I look at this example, they give us the interval -2, 2. So you have to remember that's not a coordinate. That's telling us our first x point and our second x point. So if I go to my graph, it's telling us to start when x is at -2. So that's there. And then it's telling us we're going to end when x is +2. So there. So that's telling us we're looking at all the chunk between those 2 points. So interval notation is just the x's. If I wanted to tell somebody when my graph is going up or increasing, I could look and I say, okay, well, all this is going down. I'm on a roller coaster, we're going down till I hit this point right here. And then it's going up forever. So in interval notation, we could say that it starts somewhere around 3.5, and it goes on till infinity, or forever. So we're only going to be using x coordinates when doing interval notation. And we're going to be practicing this in the whole section. So first thing we're going to look at is being able to tell when is a graph positive or when is a graph negative. And basically positive and negative is going to be determined by the y values. If we put a highlighter here on the x-axis separates our positives from our negatives. So we could say that any part of the graph that's above this yellow line, that is the positive sections of the graph. And any part of the graph that's below that yellow line, down here in the negative y values, that's the negative section. So a graph is positive when the y values are positive above that x-axis, and a graph is negative when the y values are negative, so below. And then we use our new friend interval notation to show when the graph is positive and when the graph is negative. So in this case, I'm going to write positive, negative, and if I look, I can see that it starts here being positive. We'll just go to the nearest dot for now. And that starts being positive there when x is negative 3. And if I follow it along, it doesn't stop being positive until right here when x is 0. Now, I notice that my graph drops below my highlighted line. So that means now it's not positive, now it's going to be negative, and it starts at 0. And if we follow it along, all this is down in the negatives, negative, 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 and it finally stops being negative right there at 3. So it's negative from when our x's are 0 to 3. Now we have this last little chunk, and it's going back up again. So it's back in the positives. So we can put a comma or an and, or they might use a U for unites. And we'll say it starts being positive again at 3. And we'll just say it's ending at 3.2, even though it's still going on. So anytime there's a change, we're going to put a new interval. So this is the section from negative 3 all the way to 0. Then from 0 back up to 3, it dropped into the negatives, and then it starts going back up positive. So anytime you see a gap, or you see it switches, we're going to have to stop and make a new interval. And then next time it goes positive or negative, we just make a new interval. So let's take a look at this one. We want positives and negatives again. So we're going to start over here on the left. We always go from left to right. And I see I have an arrow. So arrows automatically mean infinity. And in this case, it's a negative infinity because it's going to get smaller and smaller and smaller. And if I follow it down, it hits my x-axis. And if you want, we can highlight that so we remember that's my positive negative line. So I can see that it hits the x-axis at negative 1. Now, I see this entire chunk from negative 1, down, 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 up, 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 all the way up to 5 is negative. So for negative, we're going to say it started at negative 1, and it ended at positive 5. And now I see there's still more graph. So we're going to put our little U, and starting at 5, and it's going up, 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 and it has an arrow. So that means it goes on forever. So it's going to go on till infinity. So the negative infinity just means it's going in the negative x direction all the way to negative 1. So all of that's going to be positive. Then between negative 1 and 5, it dropped down into the negatives. And then it went back up, and it'll keep going up forever to infinity. So that's how to tell if a graph is going to be positive or negative. Now let's talk about increasing or decreasing, which we've already kind of been talking about with our roller coaster. Here's our reminder that anytime we're reading our graph, we're always going to start on the farthest left point and work our way right. And what we're going to do is we're going to think like I'm on a roller coaster. So if I start here at my bottom, which technically is going to be negative infinity because it's going in the smaller direction, I can see that my roller coaster here is going up. Then once I hit that maximum point, they're going to drop us and shoot us down. And then one last time, we go upward. So anytime it's going up from left to right, that is when it's going to be increasing. And anytime we're going down on our roller coaster, that's when it's decreasing. And here's our reminder that when we go to put this in interval notation, we're only going to use those x values. So in this problem for increasing, I look, and here's my first arrow up, and I see that arrow going in the smaller x direction. So from negative infinity, and it stopped going up at -1. Then our next chunk, as we see it started going down. So for decreasing, it went from -1 down to about 1.5. Because remember, even though we're looking, we want the x coordinate, not the y. And then up here, I can see it started going up again. So we start where we left off at the 1.5, and it's going up forever, meaning it's going to infinity again. So just like with positive or negative, anytime it switches directions, we need to put a new interval to mark it. Now we use increasing or decreasing to help us find our minimums and our maximums. A maximum is going to occur whenever we're going increasing on our roller coaster or going up, so over here, and then we go down. That is a maximum point right there, because at that time we can't go any higher. Then a minimum is going to occur when we go down and then suddenly go up, because at that point we're not going to go any further down because now they're going to shoot us up. So in this problem, our maximum is going to occur when x is 0, y is 2. And our minimum occurs when x is 2, y is -8. And this is the first time where we actually get to use the actual coordinates. So here, they're trying to confuse you, because now they're not telling you that they just want minimums or maximums. They're giving you the interval first. So what we have to do is first figure out, well, what chunk of the graph are we actually looking at? So here's our graph, and I'm going to grab my highlighter so that I can actually mark on my graph so I can see where they're talking about. So they're telling us here over the interval from -3 to -1. So remember, we only look at the x values. So we go to x is -3, and I find that on the graph, and it's right here. And then I find x is -1. So I'm going to highlight my graph until I hit x is -1. Now that I know what chunk of the graph I'm looking at, they want, well, what's the lowest point? What's the minimum there? And if I look, it doesn't get any lower than right there, and that dot is at -2, 0. Now they give us another interval. So let me grab my highlighter again. We'll change color. Now they tell us they want us to start when x is -1, and they want us to end at 0. So that's this little chunk right here. So it looks like the highest point was where we started, which was somewhere right in here. So that's a little bit before -1. So maybe -0.99, comma, and it looks like this graph is counting by 5s, so about 5. And now one more time, they're telling us we're going to look at the interval from 0 to 3. So I start when x is 0, and I'm going to highlight all the way until when x is 3. And if I look, they want the minimum. So the minimum is the lowest point in that highlighted chunk, which is right about there. So it looks like that coordinate is when x is 2. Y is down here somewhere around maybe -32. So when they give it to you like this, don't be afraid to use a highlighter. Sketch the graph out and mark what sections are we actually looking at, and then you can decide what the minimum or the maximum is in that section. Now, the next thing they want us to look for is end behavior. End behavior means we're only looking at what's going on at each end of the graph. So they want to know, what is the x doing as it's getting smaller? So as the graph goes this way, what are the y values doing? And as the graph goes this way, what are the y values doing? So if I look here, I can see that as my graph is moving to the left, as it's getting smaller, my y values, my arrow is going down. That means my y values are also getting smaller. So we could say, as x approaches -infinity, the y values decrease. And since they're getting smaller, they're also going to -infinity. So I know infinity means they go on forever. The negative is what's just telling us that it's getting smaller and smaller and smaller. So I know that if I have a point over here, if I were to say -200, I know my y value is also going to be a really big negative number. It's getting smaller. I know that it can't be positive. So now if we look going this way, as my x is getting bigger, 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 I notice my y's are also getting bigger. So as x approaches positive infinity, my y values increase, or they go to positive infinity. So we can use end behavior just to get an idea of what values are possible. Because by knowing this, now I know that it's not possible to have a point like 100, -500. As the x's are getting bigger, my y's are also getting bigger. So let's look at this graph. We're going to pretend that there's arrows here, because there really should be. So I'm going to look both as my x's are getting smaller and as my x's are getting bigger. And we want to know what's going on with my y's. Are my y's getting bigger, or are they getting smaller? So if I look this way, here's my x's. They're going to the left slowly. And I can see that as my x's are going this way, my y's are going up. So that means as x gets smaller, my y's get bigger. And if I look on the other side, as my x's are getting bigger, my arrow is going up. So that means, again, my y's are getting bigger. So as x gets larger, my y also gets larger or bigger. Now notice I haven't even looked at the answers up here. I just wrote down what I saw. Now that I know what I've seen, now I'm going to go look at the answers because I don't want to get confused. So I know that I'm basically looking as x gets smaller, meaning -infinity. So as it gets smaller, going to -infinity, my y's get bigger. That's positive. As x goes to positive infinity, y still goes to positive. So we're looking for a negative positive or a positive positive. So here I have a positive, but then a negative. And I know that's not it because it's positive, positive. Next one is x goes to positive infinity. The function's values go to positive infinity. We know that's correct. Then it tells us as x values go to negative infinity, so that's this one, the function's values go to negative, and that's not correct because it's positive. And then as x goes to positive, the function's values are equal to 0, and we know that's not true. So by writing what I know ahead of time, it makes it a little bit clearer. And don't forget, if you see problems with the box instead of a circle, that means that you could be marking more than one answer choice, so be very careful. So now let's take what we've learned, and we're going to apply it to the next section, which is analyzing tables. And if you just needed a review of reading graphs, you can stop watching here. If you're going to go on to the analyzing tables section, then keep watching. So here we have the same thing we've already been doing, our definitions. Now when we're looking in tables though, we don't have that visual. We don't have our graph where it's easy to see when it crosses the x-axis or the y-axis. We got to rely on our knowledge that x-intercept was that point where it crosses the x-axis, so the y is 0. And the y-intercept is when x is 0. So when they want the x-intercept, you're going to be looking for the point where the x is first and then a 0. Y-intercept is the opposite. The 0 comes first and then the y. If you see a problem that says f of x, you may or may not have learned function notation yet. F of x is just a fancy way of saying y. So if they want to know what the f of x value is, they want to know what the y value is. And then here's our maximum and our minimum again. Remember, maximum is going to occur if you see the values in your table. So let's say I have x equals 0, 1, 2, 3, 4, 5. And I see that my values are getting bigger. So 2, 3, 4, and then all of a sudden they start getting smaller. So it went up, and then it started going down again. So if we think about a roller coaster, we were going up, up, and then down. So that means the maximum value right here would be 2, 4. And then a minimum is going to be the same thing. Minimum would be if we had down arrow, because it's getting smaller, and then it started getting bigger. And then a turning point is just another fancy name for the maximum or minimum. It's that point where it stops going up and starts going down, or vice versa. So we've already done all of this when we're looking at graphs. Now they just want to know, can you take what we learned in the graphs and apply it to a table? So here's a table. And first thing they want to know is the x-intercepts. So we go back to our notes, and x-intercept is when we have the value, and then the y is 0. So I'm just going to go through, and I'm going to look for when I see y equals 0. And I can see that y equals 0 happens in two places. It happens at -2, 0, and 2, 0. Then it wants the y-intercept, so we go back to our notes. Y-intercept is when the x is 0 first, and then the number. So now we're going to go down my x column and just look for any place x is equal to 0. So it looks like the y-intercept is at 0, -4. So that's how we can read the table to find our intercepts. Now, let's look at reading our table here to find when it's increasing or decreasing. So before I look at anything over here, I'm just going to go to my graph and I'm going to put my arrows. So I see it went from 198 to 7, so that decreased. From 7 to 0, it got smaller. Then from 0 to 21, that got bigger. And from 21 to 298, that also got bigger. So that means in this area right here, it was decreasing. Then right about here, it turned. And then it started increasing. So now it wants to know when is f of x, and remember f of x is just a fancy way of saying y. So we can say that it increased using our function notation from -4 up to 0, because that's where it turned. And then starting, oops, did I do that backwards? I did. Increasing is our up arrows. That's my bad. So increasing, it started going up at 0 when it turned, and it increased to 4. And decreasing, got to go backwards up here from -4 to 0. So notice right here, those zeros, that becomes our potential turning point. 0, when x was 0, the y was also 0. So don't be afraid to mark these little arrows to help you see when is it going up, when is it going down, and then we're still using our good friend interval notation. And then the last thing that this section is going to want you to be able to do is do that end behavior again. So basically that means when the x is getting smaller, as the x gets smaller, what does the y do? And as x gets bigger, what does the y do? So if I look, here's my x's. I see they're getting smaller. So we know we're going to -infinity because it's getting smaller. But if I look here, my y values from 7 to 32, it went up. From 32 to 81, it went up. It went up, so I can see that these are getting bigger. And we do bigger by putting a positive infinity. And then as my x's are getting bigger going this way, I look to see what's happening on my last few, and I can see that in between each one, it's getting smaller. So we say as x gets bigger, the y gets smaller. So that's -infinity. So end behavior really means we just look at the ends, and as x gets smaller, are my values going up or are they going down? Up means positive infinity, smaller means -infinity. So hopefully this has been a good overview of what you need to do when you're trying to analyze a graph or a table. Thanks for watching.